Dear friends, welcome to this electrical engineering knowledge sharing channel. We are discussing workshop 8. Under the present session, we are going to discuss about the control cable block diagram for 11 kV switchgear. In the previous session, we have discussed about the power cable block diagram for 11 kV switchgear, and today's point of discussion is control cable block diagram. So this control cable block diagram, as I explained in the previous video, that cable block diagram has an important drawing from which we can visualize the entire cabling arrangement for the plant from originating from the 11 kV switchgear or 6.6 kV switchgear or any other voltage level of switchgear. How many control cables are required? Where are the control cables are going? What is the mode of laying? What is the length of the control cable, and then how the control cable is distributed in the various equipments, and what are the functions of the control cable. All these things we can pictorially represented, could be represented on the control cable block diagram. For the simplicity of our discussion, I have considered three typical panel. One is the generator control panel, a generator panel switchgear, that means the panel which is containing the generator breakers and other power equipment along with the control system. That is one panel. We have considered 11 kV panel. Then we have considered another panel for the transformer panel, which is containing the transformer supplying circuit breakers, power equipments and our control part. And the third is for the motor panel. And we can also add another panel over here. That panel will be your substation panel, which is feeding power to the substation, suppose substation 1. So this is a switchgear, suppose SW1D. These are the four panels we have considered, but it will be copy same for the multiple generator. The same type of generator, switchgear panel A is a generator panel. Same type of panel will be copied. For the motor panel, same type of arrangement will be copying. Transformer panel, whatever the arrangement for this panel, same will be copying. Similarly, for the other substation also, same thing will be copied. That's why for typical analysis and the clarity of the drawing, I have shown four typical switchgear 11 kV switchgear panel. How this panel is connected with the various field equipment, considering the control, indication, metering purpose only. The major power and the control power, major power and the CTPT supply already discussed in the previous video. So this video is only for the control, indication, monitoring and metering purpose. Only this purpose we are using this control cable block diagram. Now let us discuss first the generator switchgear. So generator panel we have discussed 11 kV switchgear is tagged as SW1. In this switchgear, the first panel SW1 is the switchgear tag and A panel means it is a generator panel. This switchgear 11 kV generator panel, how many cables, control cables are required? First, look into the load side. It is connected the generator. So on the generator skid, if you look into the generator, is it a gas turbine or it could be steam turbine or it could be diesel generator, whatever the type of generator you take, on the generator skid, there are couple of equipments, couple of control cable is going or coming from the generator skid. What is that? Number one, in this generator from the electrical point of view, this generator has a space heater. That space heater needs power supply from the switchgear. So that is all of the power supply is going to the generator skid, that is space heater cable. Then on the space heater, on the winding there is a RTDs. These RTDs is giving the signal to the generator or through the control panel to the generator for the monitoring of the winding temperature. Along with this, the generator is mounted with the turbine. So turbine and the generator in between there is a bearing. So bearing temperature also important parameter which is need to monitor. So bearing RTD, there is also RTD in the bearing. The bearing RTD also we measure. So, and if it is in case of motor, there is a driving and non-driving, and if there are two bearing, then there will be two RTD. So that means for the winding temperature as well as bearing temperature measurement, we need the RTD signal. The RTD is mounted in the inside the generator winding and inside the bearing. From there, this RTD signal is coming to the either to the switchgear or to the control panel, and from the control panel it is coming to the switchgear. So we are considering the signal is coming to the switchgear. So there is another RTD cables. Then on the generator skid there is the emergency stop. In case of any emergency or any accident, immediately the emergency push button which is mounted on the generator skid, that is to be pressed, and the immediately generator is tripped. So that tripping command is coming to the switchgear. So there is another emergency trip command. So these are the, and in addition to this, if this switchgear panel, 11 kV switchgear panel contains the generator control component like a automatic voltage regulator and your governor, in that case, this generator switchgear panel, this also required to be control cable coming from the skid for the controlling. There is a CT supply, current signal and voltage signal is coming to the generator panel to connect with the AVR and the your governor. And because the governor signal is taking, governor speed is controlled by the frequency, so PT signal is coming, voltage signal. Along with this command from the governor is going to the regulating valve, fuel regulating valve. The valve is a solenoid. In that solenoid, a signal is going for the opening, closing, or the opening portion control. So that signal also going from the AVR, your governor. So if that AVR and governor is a part of the generator switchgear panel, then that cable also to be connected. So if we look into this generator switchgear panel connected with the generator skid with the 4 different cable. One is a space heater cable, that is 1 3-core 4 square millimeter, because there is one space heater which is heating this supply, which is supplying power through this cable. Then there is the RTD. Now this RTD I am considering 3 wires RTD. So there will be, in each phase there are 2 RTDs, but normally 1 RTD we take to the temperature sensor. That means 3 phase, there will be 3 RTD and there are 2 bearing RTD. So total 5 RTD, and this RTD is a 3 wires RTD. So there are 15 wire will be required. We have considered one 18-core cable, 1.5 millimeter square, 18-core into 2.1. This RTD signal is a 1.5 square millimeter cable is enough. That cable we have considered over here for the temperature monitoring of the winding and the bearing. Then there is a emergency stop. I already told that if you see our breaker tripping scheme, in the breaker tripping scheme there is a emergency stop command is coming from the generator skid. So that to bring that push button command, we need a 1 3-core cable. That is also we have considered over here, 1 3-core 2.5 square millimeter. These are the 4 mainly control cable we are using in the case of generator panels. Now these cables, the length between the switchgear panel and the generator is the same length as we consider. Suppose this length is a 200 meter. So we will write over here length is a 200 meter, and this cable we are considering all the cables are laid over the cable tray. So it is over. So we can put a common note over here. All the cables are laid on the cable tray, or we can give the symbol, cable tray symbol. We have already told in the previous video, this is the symbol for the we have used over here. When this symbol is there, that means we understand the cable is laid on the overhead or above the ground cable tray. Here we are considering all the cables are laid on the overhead or over the ground cable tray. So that is the symbol we have used over here everywhere. This is a cable tray. So from this is one of the set of cables which is coming from the generator panel A to the generator skid. There are 4 cables. One is a control cable 1.7 square millimeter to carry the signal for the AVR and this governor, and in addition to any other control signal is coming that will carry this thing. Second is a space heater signal for the heating the generator space heater to keep it warm so that humidity will not condense on the winding. For that 1 3-core 4 square millimeter cable. Then the temperature winding and bearing RTD, bearing temperature monitoring. There is RTD. This RTD purpose is a 1 18-core cable, and then emergency stop cable. These are the 4 cable coming from the generator skid to the generator switchgear panel. In addition to this, we have seen this generator panel, it can be controlled from the generator switchgear panel itself, as well as it has a control from the remote. We have seen the remote. There is a control room. In the control room, there is a control panel or DCS from where we can open and close the circuit breaker. Similarly, there is a power management system from where also we can open and close the circuit breaker. So that is another control in the PMS. And then we have seen in case of fire and gas, where the switch gear is located or this generator is located. In that area, if there is a fire, then the fire and gas system will be operated. The fire and gas system will give the tripping command or abnormal command through the ESD system. The trip command should also come to the generator panel to trip the breaker. So if we look into that way, so the generator panel, in addition to the generator, it has also hooked up with other control panels, other control devices, which is located in the control room or some other room. What are the control room we are considering here? One is a control room control, that is from the DCS. In the DCS, we have a opening closing signal. Then from the PMS, power management system, we have an opening closing signal. And from the DCS also, in addition to the opening closing, we do monitor all the status of this circuit breaker, this panel status also we monitor over here. All the, as well as if require some parameter over here, the winding temperature, high or low, generator breaker on or off, this status also we can monitor over here. So this DCS panel or control panel in the control room, that has a one control plus a status signal is coming from the generator panel to over here. Out of that, a status of this generator panel breaker on or off status, as well as suppose there is a relay operation or not, the lockout relay operated, that signal will come through a control cable. Along that status signal we bring coming from here to the DCS panel, that is as a potential vary contact coming from here to the DCS. And on the reverse way, from the DCS we give the open close command, that command also coming from the DCS to the switchgear. So all this command and the status signal we bring through a control cable. That's how we have considered one control cable from generator control panel, generator switchgear panel, one 18-core cable. We have considered this is a control cable, control and status cable we have shown over here coming to DCS from the generator panel. This cable is a 118-core cable. This is 118-core 2.5. This generator switchgear panel is carrying one control cable, 118-core cable, 18-core into 2.5 square millimeter electrical control cable is connected between the switchgear, generator switchgear panel to the DCS. This is the cable. This cable will carry what? DCS open close command, which is going to the switchgear panel for the operating the circuit breakers, as well as from the generator panel various status signal. Some breaker is on, breaker is off, breaker is tripped, or breaker trip circuit supervision not is healthy, trip circuit is healthy, or breaker operating mechanism is healthy. All these status we can bring from here to the DCS monitor. So that is coming through this 18-core cable. Similarly, in the case of ESD, we have said already that ESD is how it is operating. If there is a fire and gas signal, there is a fire, suppose the generator is killed, there is a fire, then the generator is killed will send the fire and gas signal to the ESD system. Then ESD system will operate and ESD system will give a tripping command to the respective generator breaker. So from the ESD, this is the ESD panel which is located in the control room or ESD room. From that ESD panel, one control cable is coming which is giving the tripping command or abnormal fault command, abnormal status of the operation is giving tripping command to the generator switchgear panel. So this is another cable. As it is only one signal is bringing, we are considering 134 2.5 square millimeter cable. And this cable also we can write the length over here. In the DCS also we can suppose the DCS panel or the control room is located at 500 meter. So we will write down here the length of this panel is the distance between this generator switchgear panel to DCS is L equal to 500 meter. Suppose here to ESD panel also length, it can be 500 meter if it is located in the control room. If it is somewhere else, the length will be different. So this is the ESD cable, this is the DCS cable. In the power management system also we can open close the breaker from the power management system, as well as if the power management system is located in the electrical control room or separate room. In that case, the power management system also monitoring the various status as we monitor the status in the DCS. So that monitoring and the control of the circuit breaker close open also we do from the PMS. So there is also one control cable, same 18-core control cable between the switchgear to the PMS. That control cable we are showing over here. You see this is the control cable, control and indication cable coming to the PMS panel. That is a control and a status. It is a 18 core cable. That same 18 core 2.5 square millimeter cable, and this PMS may be located in a separate PMS room. Suppose this length is a 300 meters. So we write down over here 300 meter. So these are the control and indication point of view and tripping point of view. In addition to this, in the power management system, we monitor the various electrical parameter of the switchgear. That means current, voltage, kilowatt, kVAR, power factor, frequency. All these things we can monitor from the generator switchgear panel to the PMS panel by another. Either it is serial cable or by the coaxial cable through which the signal is coming. So there is another 7-core coaxial cable, or we have considered coaxial cable, 7-core cable is bringing the PMS signal. Whatever the signal we want to bring, we can bring through this cable. So in the PMS, there are two cables. One is a metering cable for metering the various parameter of the switchgear panel, and another is a control and indication cable. So these are the total 6 cables, 2 for PMS cable, 1 for DCS cable, and 1 for ESD cable. This 4 cable also originating from this panel. Okay, so these are the generator cables. So we show in this way. Now we come to the motor. In the case of motor, same way. Now we can remove this cable, so it will be more clear. This is going to the generators. So the generator 4 cables we can delete from here. So it will be more clear to understand. So this is deleted. Okay. Now we come to the motor panel. In the motor, same way, motor has a motor switchgear panel, that is a panel B. It has also interface with the motor skid, as well as it interface with all these 3 devices, ESD, DCS and PMS. From the motor skid, why it is connected? On the motor, when the motor is a rotating device, so near the motor, in some of the cases, motor start stop, we can do from the motor skid itself. So there is a start stop command is coming from the motor push button. So there is a push button station near to the motor. In addition to this, sometimes this motor skid has the emergency push button for the control purpose. So that is also coming from the motor. So for the on-off control of the motor, for the controlling purpose of the motor, for on and off control of this motor feeder, because if you want to start the motor or stop the motor, ultimately how? By closing the circuit breaker or opening the circuit breaker. So the push button may be located near to the motor station, but from this station the cable will be coming over here. For that purpose we use one 7-core cable, which will give a command from the motor skid for the breaker on and off, or circuit breaker or the feeder on and off. In addition to this, for the case of emergency push button, from the motor skid there will be another cable will be connected over here for the emergency push button, which is 1 3-core into 2.5 square millimeter, same like a generator. That is for emergency push button. That is also connected to the motor switchgear panel. So there are two. Normally emergency push button cable we always let separately, as it is emergency purpose. We do not mix it with the other cable. It is a separate cable. So the emergency push button, one control cable for the emergency stop, and in addition to this, another one control cable for the circuit breaker on and off from the for the local starting of the motor, local stopping as well as local stopping of the motor. In addition to this, same way, the motor has a spacitor and motor has a both side bearing. If the motor has a higher capacity, 2 megawatt motor, 2 megawatt or more motor bearing has a RTD. That RTD signal, there is a driving and non-driving, and there are 2 bearing. That and that bearing, RTD driving and bearing or non-driving and bearing, both the bearing as well as winding RTD, there are total, actually there are total 8 RTDs, 2 RTD on each phase. There are 3 phases, means 6 RTD, and 1 driving in RTD, another non-driving in RTD, total 8 RTD. But normally this dual RTD on each phase has a duplicate purpose. For each one of the winding, if one of the RTD fails, then we cannot put the new RTD in the winding. It is very difficult. That's why during manufacturing of the motor manufacturer always put 2 RTDs in each winding. So if one RTD fails, the other RTD will be available. So we normally use one of the RTD on each phase. So 3 phase 3 RTD plus 2 5 RTD. That's why you are using one 18-core cable. RTD signal is bringing by 118, same like before. One 18-core cable is coming to the switchgear panel to monitor the bearing and the RTD temperature. Then there is also in the motor winding there is a spacer. For the spacer supply also coming from the motor. Now the spacer, because why it is coming from the generator panel, because it is interlocked with the generator circuit breaker contact. This spacer will be on only when the breaker is off, because when the breaker is running, when the breaker is on means motor is running. At that time there is heating is already inside the motor winding, so you don't need to separate heating. But when the motor is off, at that time you need the heater to be on. So this heater circuit for the motor is getting power from the switchgear through the switchgear, from the switchgear auxiliary supply operated by the breaker auxiliary NC contact. So when the breaker is off, immediately the heater will be on. So there will be one 3-core cable, 3-core 4 square millimeter cable, which is coming from the switchgear and taking the switchgear auxiliary power to heat the RTD of the motor. So there is another cable for this purpose. And so these are the 4 cables I consider. We have considered here. One is a control cable for the circuit breaker on off from the motor skid. Second is a space heater cable, one 3-core 4 square millimeter cable, space heater, and then one 18-core cable for the RTD signal and one emergency push button signal. These are the for the motor side. In case of power diagram, we don't have this part. This part was not there. Only we were concentrated on the equipments only, because these are all control equipment. So power cable is not connected over here. That's why this part was not related in the case of power block diagram. But in the control cable block diagram, as the main power equipment is connected, as well as various control equipment also connected. Okay. Now come to the control part. Now same way motor panel also, from the DCS, we want to control this motor. We can on or off the motor. So one motor start stop we can do from where? From the DCS means we have to close the breaker over here. So there is a control cable going from here to DCS. So this control cable, this is that control cable. This control cable, same one 18-core cable we are laying over here. This control cable is a 18-core into 2.5 square millimeter cable we are laying from here. This cable, what it will carry? It will carry breaker on-off control from the DCS, as well as various status of this panel, of this particular panel. Whatever they suppose we want to monitor in the DCS the winding temperature. As the winding temperature sensor signal coming to the generator panel, from the generator panel we can copy this signal to the DCS. Motor temperature high, bearing temperature high, circuit breaker on, circuit breaker off, circuit breaker protection, this motor feeder protection operated, motor feeder tip circuit healthy. All these indication we can bring in the DCS. So this 18-core cable carry the on and off command control as well as various status of this panel. So this is 18-core cable. Similarly, if suppose the motor is located in the hazardous area, whatever the area, suppose there is a fire, okay, in that case what will happen? If there is a fire, immediately the fire signal will be sending to the ESD system. Then the emergency shutdown system will be issuing a tripping command to this motor panel. So there will be one cable going from here to ESD system. That is also one 3-core cable like before, like the generator panel. From the motor panel also one ESD signal is going to the ESD panel. That signal is coming from ESD panel to the motor switchgear panel to trip the circuit breaker in case of emergency shutdown. So this ESD cable will be 1 into 3-core into 2.5 square millimeter cable. This is the ESD cable. Similarly, in the PMS also, we want to control this circuit breaker like the generator panel. So in the PMS there will be control cable who will be doing the control of the circuit breaker on off, as well as it will monitor the various parameter of this panel as we required, breaker on, breaker off, whatever the status we are monitoring over here, we can also monitor over here. So this is also another 18-core cable. This is the cable we have shown over here. This is the 18-core 2.5 square millimeter cable, which is led from the switchgear panel, motor panel to the PMS to monitor the generator breaker various status as well as control of the generator panel. Similarly, there is another cable is coming from this motor panel, that is the metering cable. This is the metering cable is coming from the motor panel to the PMS panel to monitor the monitor the various parameters, current, voltage, electrical parameters, monitor over here. That is also 7-core into 2.5 square millimeter cable or 1.5 square millimeter cable also we can use. It is a small minor signal. It is a milliampere signal is carrying through the transistor. Actually this original CTPT supply is coming to a transducer. This transducer is giving the required output to monitor this. So this cable current is not very high, even 1.5 square millimeter cable we can lay to monitor this various electrical parameter in the PMS. So this is the cable. So in the case of motor feeder, generally there are 4 cable to the skid going, and here we have a 1 cable for the DCS, 2 cable for the PMS, 1 cable for the ESD. There are 4 cables we are laying. Now come to the transformer panel. In the case of transformer panel, transformer winding temperature we do not monitor. So only thing in the case of transformer, what we need from the transformer skid, there is one control cable is coming to monitor the various status of the transformer. Like transformer has various devices mounted on the transformer, various indicators like a oil temperature indicator, oil level indicator, winding temperature indicator, pressure relief device or Buchholz relay. These are the 4 major devices mounted on the transformer. Each device has a 2 contacts like a winding temperature. Winding temperature has a 2 level, winding temperature alarm, winding temperature trip. So there are 2 contacts from the indicator is coming. Similarly, oil temperature indicator, it has a alarm contact, trip contact. Oil level indicator, it has a oil level low. There are 2 contacts. Pressure release device or Buchholz has operated, that is also contact. All these status we bring to the switchgear for either for the tripping purpose or for monitoring purpose. So then for that reason we have considered one 12 core cable. There are 4 devices, 8 contact, so 16 core cable. Normally better it is use one 18 core cable from the transformer marshalling box to the transformer switchgear panel to either to monitor the various status, or maybe we need to multiply this contact, that also possible, as well as if we want to use this contact through the interposing relay for other purpose. But ultimately this contact need to come to the switchgear, so that all contact we bring in the switchgear. For that purpose, one control cable is required from the transformer skid to the transformer switchgear panel. That is only. Here there is no space heater, there is no emergency stopping business for the transformer, and if you want to put emergency stop, then you can put it. In that case, this emergency stop, if there is any emergency in the transformer, in this case the transformer there will be one cable for the emergency stop. That you can include over here, emergency stop. 1 3 core, that cable will be 1 3 core into 2.5 square millimeter, that, and the status. There is no, from the transformer skid we do not control the circuit breaker. Okay, so these are the transformer cable. And for the control purpose, here the same thing, we can delete this part. From the transformer, what we'll do, similarly we have a one control cable going from the transformer switchgear panel to the ESD panel. That is a 1 3 core into 2.5 square millimeter. What is this? Suppose there is while the transformer is located, there is a fire. In that case, if there is a fire, similarly the fire and gas panel will give a command to the ESD system. ESD system will activate, and then ESD system will sending a tripping command to this breaker. So that tripping command will be carrying by 1 3 core 2.5 millimeter cable over here. Then similarly from this transformer panel, switchgear panel will be controlled from the DCS, from the on-off control of this breaker, as well as the breaker various status also monitoring from here. For that purpose, we are laying one 18 core into 2.5 square millimeter cable. Okay, that is the DCS cable. Similarly, from here, there will be PMS. There will be 2 cable will be there. One cable for the to control the circuit breaker from the PMS and to monitor the various status of this panel to PMS. For this control and status purpose, one 18 core cable, 2.5, and for this metering purpose, one 7 core coaxial cable. That is also we are laying between the transformer panel and PMS panel. Similarly, others. Okay, these are the various cables. Now, in case of substation panel, what is there? In the case of substation, this I am deleting this thing. Now, for the substation panel, we have seen this substation panel supplying power where? In the remote substation, which is in the same voltage level. In the last video, we have considered the substation is a offshore platform. So if suppose this is the substation 1, where it is located in the offshore platform. So this cable we are considering here, there will be a cable between these two, but this is not the surface cable. This cable is a subsea cable, and that subsea cable yesterday in the previous video we have considered this control cable 118 core cable we consider as inbuilt with the subsea cable. So that cable is already included, and through this single 18 core cable, whatever the status we monitor over from here to here, that signal is going, as well as if we want to control remotely this circuit breaker, then also that command is coming through this. So this is the way, and we said the protection signal is coming through the fiber optic cable. There is a 124 for fiber, 24 fiber is also inside the subsea cable. That fiber cable will be carrying the protection signal as well as various communication signal. That cable is also between these two. And from here also, this breaker we can control same way from the ESD system. We can control from DCS, and we can monitoring the various parameter over a same way from the ESD. If this substation there is a fire, okay, suppose this is a far away, this substation, if there is a fire, immediately this substation through the ESD system, they will send some signal through the fiber optic cable. This cable will be coming to the ESD panel, and from the ESD panel the signal will come over here to trip the breaker. That is one of the way we can do it. Another way, if there is a fire, the ESD signal substation area, that is oiled, it is a offshore platform. There is also another ESD system. That ESD system can give the output command. That output command can come through the 18 core cable, and it will trip this breaker. In that case, this interface will not be there. The interface will be coming through directly. But if this ESD system over here or fire and gas system over here send the trip command through the fiber optic cable to the local ESD system, then through the local ESD system it should be tripped. So there could be a one cable from here to here, or the single cable will carry the signal. That is one thing. Second thing, in the DCS, same way, this breaker on and off control as well as various parameters of this panel, that is a various status, breaker on off, etc. As we said, breaker, what are the various status we have discussed? On, off, then trip circuit healthy, trip circuit healthy, we have seen healthy, that signal. Then lockout operated or protection operated, you can say protection operated. Okay, all this signal we can bring over DCS, all this status from here, and similarly from the DCS we can give the open command, close command. So this open command, close command, and this signal are coming through this 118 core cable. And in the PMS also same way, from the PMS also we can control the circuit breaker, as well as we can meter the various parameters in this substation panel, switchgear panel. So here will be also two cable, one cable, 118 core cable, and these will be 17 core coaxial cable for metering the various parameters. So this way for each panel, these are the list of cables. So from this it is very clear, for most of the panels in the ESD, DCS and PMS, in the ESD one cable, DCS one cable, and PMS there are two cables. That means four cables over here. And for each type of equipment, for here it is only one cable. In the case of generator there are four cables. In the case of motor also there are four cables, right? So this way, if we calculate for the one generator, then if we have a multiple generator, we can estimate how much cable and what is the requirement. Similarly, if we calculate for one motor, if there is a multiple motor, we can multiply this way. Similarly, how many substation we are supplying, we can calculate in the same way. In case of transformer, how many cables? In the transformer, there is one common 18 core cable, and here there will be four cable. So for one transformer, if I calculate this cable, then how many transformer feeder we have? Based on that, we can estimate the cable. So in the same like a previous video, what we can do, we can make a finally one table, and from the table for each type of equipment we can estimate the amount of cables required for the various types of cable, and then we can multiply that amount for number of loads we have. From that we can calculate the total amount of cable, and from the designation we can calculate, we can see the arrangement, or we can see the arrangement for the your distance, and distance also we can see. From the symbol we can make out whether the cable is directly laid or it is over the tray. We have said already. So for the directly laid cable, how we will show this thing? We put a dot up top and bottom, and we put the cable like this. This shows the cable is directly buried underground. In case of cable laid in the duct bank, we show this thing with a concrete over inside. And in case of subsea cable, how we have shown this thing? We have shown in the previous video. subsea cable is there, then this is the dotted line, and on the top we put like waves. These indicate this is a subsea cable. So these are the symbol we use for the cable block diagram, and from this overall diagram we can calculate all these things. So this is the brief of the cable control cable block diagram, and I hope this control cable block diagram and power cable block diagram will help all of you to understand what is the importance of this diagram and how we can use this diagram and how to develop this diagram. So please go through this. If you have any queries, please raise to me through your comment. I'll try to respond. And with this, I am closing this video. And thank you very much to all of you for continuing with me, and keep it up. Thank you very much indeed. Thank you.